Welcome to the Universe Unveiled. Today we embark on a 20-minute odyssey through the most profound mysteries of our solar system. Our journey begins on the Red Planet, a world that has captivated human imagination for centuries with its rusty and dusty surface. In 2018, NASA sent a robotic geologist named InSight to the Elysium Planitia region to study the deep interior of Mars. Unlike the rovers that wander the surface, InSight was designed to stay in one place and listen closely to the planet's heartbeat. Its primary tool was a highly sensitive seismometer, placed directly on the ground to detect the faintest vibrations traveling through the crust. For the first time in history, we could hear Marsquakes, seismic events that reveal the hidden geological activity of a dead world. The data returned was astonishing, showing that Mars is not completely solid, but is still trembling and shifting deep beneath our feet. By analyzing how these seismic waves move through the planet, scientists could finally map the thickness and composition of the Martian crust. The most groundbreaking discovery was evidence suggesting that the core of Mars is likely liquid, larger and less dense than previously thought. This liquid core contains lighter elements like sulfur and oxygen, mixed with iron, challenging our models of how rocky planets actually form. Before InSight, Mars was silent to us. Now we know it is a dynamic world with a history written in its vibrations. InSight also detected meteoroid impacts, allowing scientists to correlate seismic signals with fresh craters spotted by orbiters circling high above the planet. Eventually, the accumulation of dust on its solar panels ended the mission. But the legacy of InSight changed planetary science forever. While science provides answers, the vastness of Mars has also birthed countless theories that challenge the official narratives provided by space agencies. Rumors have persisted for decades that NASA might be withholding evidence of ancient civilizations or strange artificial structures on the Red Planet. Internet sleuths scour thousands of public images, looking for shapes that do not fit the natural geology of a barren landscape. One such anomaly is the so-called Mars Henge, a formation of stones that appears to be arranged in a deliberate circle. Although likely a natural occurrence of erosion, the resemblance to ancient megalithic structures on Earth fuels the imagination of conspiracy theorists everywhere. Geologists argue that freeze-thaw cycles and wind erosion can naturally sort rocks into patterns, creating illusions of intelligent design. Even more compelling are the alleged pyramids of Mars, triangular mountains that some claim are too symmetrical to be mere geological accidents. These formations appear in various regions, leading some to speculate they are the ruins of a lost civilization buried by time. The famous face on Mars was once the center of this debate, until better cameras revealed it to be a natural mesa. This psychological phenomenon is known as pareidolia, where the human brain is hardwired to recognize familiar patterns in random visual noise. However, the persistency of these sightings speaks to our deep desire to find out that we are not alone in the universe. Some theories go further, suggesting that NASA has already found life and is keeping it secret to prevent global social panic. Until humans physically set foot on Mars and excavate these sites, the line between rock and ruin will remain a mystery. Leaving the Red Planet behind, we turn our gaze outward to a visitor that came from beyond our own solar system. In October 2017, astronomers detected an object moving so fast that it could only have originated from interstellar space. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, and its appearance was unlike anything seen before. It was 10 times longer than it was wide, a shape never observed in natural asteroids or comets within our system. Its trajectory was hyperbolic, meaning it was not bound to our sun and was destined to leave us as quickly as it arrived. As telescopes tracked it, they noticed something strange. Oumuamua was accelerating as it moved away from the sun, defying gravity. Comets accelerate by venting gas, but Oumuamua showed no sign of a tail, no coma, and no visible outgassing whatsoever. This anomaly led Harvard professor Avi Loeb to propose a controversial hypothesis that Oumuamua might be artificial in nature. Loeb suggested it could be a light sail, a piece of advanced technology pushed by the pressure of solar radiation. Could it be a defunct probe from a distant civilization? Space junk drifting through the galaxy like a message in a bottle. The scientific community largely disagreed, proposing natural explanations like hydrogen ice or nitrogen ice to explain the invisible acceleration. If it were made of solid hydrogen, it could outgas invisibly, but such an object has never been seen forming in nature. The mystery sparked the Galileo Project, an initiative dedicated to searching for physical evidence of extraterrestrial technological artifacts near Earth. Whether rock or machine, Oumuamua is now gone, lost to the dark void, leaving us with more questions than answers. Our tour brings us closer to the Sun, to Earth's evil twin, Venus, a planet often ignored in the search for life. With surface temperatures hot enough to melt lead and crushing atmospheric pressure, Venus seems like the last place to find biology. Yet, during the Cold War, the Soviet Union achieved the impossible by successfully landing a series of probes on this hellscape. The Venera missions were engineering marvels, built like tanks to survive the descent through clouds of sulfuric acid and extreme heat. They survived for only a few minutes to an hour before succumbing to the heat, but they beamed back historic images. These photos remain the only images we have from the surface of Venus, revealing a cracked, desolate, and alien wasteland. The Soviets proved that humanity could touch the most inhospitable surfaces, a feat that has not been repeated in 40 years. While the surface is dead, recent studies suggest that the upper atmosphere of Venus might be a haven for microbial life. In 2020, astronomers announced the detection of phosphine gas in the Venusian clouds, a potential signature of biological processes. On Earth, phosphine is produced by bacteria in oxygen-free environments, leading to speculation that life floats in the clouds of Venus. The discovery is fiercely debated, with some studies suggesting the signal was sulfur dioxide or a processing error in the data. To solve this riddle, NASA and ESA are preparing new missions to return to Venus and sample the atmosphere directly. Venus reminds us that life might exist in the most unexpected niches, thriving on the edges of what we consider habitable. We now leave our planetary neighborhood to confront the invisible skeletons that hold the entire universe together. Dark matter. Everything we can see, touch, and measure makes up only 5% of the universe. The rest is a dark mystery. Dark matter acts as the invisible scaffolding of the cosmos, its gravity pulling normal matter together to form stars and galaxies. The James Webb Space Telescope was built to peer back in time, and it has found things that defy our understanding. Webb has observed ancient galaxies that are too big and too bright to exist so soon after the Big Bang. These impossible galaxies suggest that structure formed much faster than our standard models of cosmology could ever predict. One theory proposes the existence of dark stars, celestial giants powered not by fusion, but by the annihilation of dark matter. These theoretical monsters would be millions of times more massive than our Sun, and could explain the early supermassive black holes. If they exist, they would be the first stars to illuminate the universe, born from the dense dark matter of the early cosmos. James Webb is currently hunting for their unique heat signatures, potentially proving that dark matter is not just gravity, but fuel. From the microscopic dance of particles to the majestic swirl of galaxies, we are slowly peeling back the layers of reality. Each mission, each anomaly, and each discovery brings us one step closer to understanding our place in this vast, strange theater. The universe is not just a collection of dead rocks and gas. It is a dynamic, evolving story waiting to be read. And as we look out into the void, we also learn to appreciate the rare and fragile beauty of our own home. The age of discovery is far from over. In fact, with new technology and bold ideas, it has only just begun. Every planet holds a secret, every asteroid tells a history, and every star whispers the physics of the impossible to us. Consider Jupiter, the king of planets, shielding us from comets while harboring icy moons that might conceal vast subsurface oceans. Europa teases us with the promise of liquid water hidden beneath miles of ice, another potential cradle for extraterrestrial life. Future missions will taste the plumes of water erupting from Europa, searching for organic molecules without ever drilling the ice. Saturn's rings, the jewel of the solar system, are younger than the dinosaurs, a temporary cosmic accident we are lucky to see. Its moon Titan has rivers and lakes, not of water, but of liquid methane, suggesting a chemistry of life completely alien to us. NASA's Dragonfly mission will soon fly through Titan's thick atmosphere, hopping from location to location to study its prebiotic chemistry. Uranus rolls on its side, the victim of a massive ancient collision, guarding the secrets of the ice giants in silence. Neptune, with winds faster than the speed of sound, marks the edge of the planetary realm, a gateway to the unknown. Beyond lies the Kuiper Belt, the home of Pluto and Arrokoth, remnants from the very dawn of our solar system's formation. When New Horizons flew past Pluto, it transformed a fuzzy dot into a complex world with nitrogen glaciers and blue skies. Further still is the Oort cloud, the reservoir of long-period comets, extending halfway to the nearest star, Alpha Centauri. Humanity's farthest emissary, Voyager 1, has crossed the heliopause, carrying a golden record of our sounds and images to the stars. It still whispers back to us with 20 watts of power, proving that our reach extends beyond the gravity of our sun. But the ultimate question remains: are we the only consciousness capable of observing and understanding this grand cosmic architecture? Programs like SETI listen for technosignatures, hoping to catch a stray radio wave or laser pulse from an advanced neighbor. The Drake equation suggests the galaxy should be teeming with life, yet we are met with the Great Silence, or Fermi paradox. Perhaps civilizations face a great filter, a challenge so difficult that most destroy themselves before they can become interstellar species. Or maybe they are watching us, treating Earth like a protected zoo, waiting for us to mature before making contact. Our best chance of survival is to become a multi-planetary species, starting with the colonization of our neighbor, Mars. Private companies and national agencies are racing to make this a reality, turning science fiction into the history of tomorrow. But first, we return to the moon. The Artemis program aims to establish a permanent presence on the lunar surface. Water ice at the lunar poles will provide the air we breathe and the hydrogen fuel to push us deeper into space. Seeing Earth from the moon shifts our perspective, reminding us that borders are imaginary lines drawn on a single shared planet. We live in the atmosphere of a star. The sun's weather dictates our technology, our climate, and our very survival. The Parker Solar Probe is currently touching the sun, flying through the corona to unlock the secrets of the solar wind. Our sun is just one of billions. The galaxy is populated by red dwarfs, blue giants, and the remnants of dead stars. Neutron stars pack the mass of the sun into a city-sized sphere, spinning hundreds of times every single second. When these dense objects collide, they forge the heavy elements of the universe, including the gold in your jewelry. At the heart of our galaxy lies Sagittarius A star, a supermassive black hole that dictates the orbits of nearby stars. The event horizon marks the point of no return, where gravity is so strong that not even light can escape. We have finally photographed this shadow, proving Einstein's theory of general relativity correct in the most extreme environment imaginable. Could black holes be gateways? Theoretical physics allows for wormholes, shortcuts that could connect distant parts of the universe instantaneously. While mathematically possible, traversing a wormhole remains science fiction, requiring exotic matter with negative energy to keep the throat open. Back in our solar system, the asteroid belt offers a different kind of treasure: infinite resources for a spacefaring civilization. Psyche 16 is a metal world, likely the exposed core of a dead planet, containing enough iron to build a Death Star. NASA is sending a mission to explore this metal world, giving us a unique window into the violent history of planetary formation. But asteroids are also a threat. A rock the size of a mountain ended the reign of the dinosaurs in a single day. We are no longer helpless. The DART mission proved we can deflect incoming asteroids, potentially saving humanity from extinction. Comets, the dirty snowballs of space, bring water and organics to the inner planets, possibly seeding life on early Earth. Is the water in your glass alien? Scientists are still determining how much of Earth's oceans was delivered by cometary bombardment. In 5 billion years, our sun will run out of fuel, expanding into a red giant and consuming the inner planets. It will end its life not with a bang, but by shedding its layers to create a beautiful planetary nebula. At the center, a white dwarf will remain, a cooling ember the size of Earth, fading slowly into the eternal darkness. This is the fate of all stars. Entropy will eventually win, leading to the heat death of the universe in the distant future. But that end is far away. Right now, the universe is alive with the birth of new stars and colorful stellar nurseries. In the Orion Nebula, thousands of new solar systems are forming, potential homes for future civilizations we will never meet. We have discovered over 5,000 exoplanets, worlds made of diamond, worlds of endless ocean, and worlds where it rains glass. Kepler 452b is Earth's older cousin, a super-Earth in the habitable zone that might have hosted life for billions of years. The TRAPPIST-1 system packs 7 Earth-sized planets into a tight orbit, offering multiple chances for life to emerge in one system. We find these worlds by watching their shadows pass in front of their host stars, measuring the tiny dip in brightness. Soon, we will sniff their atmospheres, looking for the chemical fingerprint of biology: oxygen, methane, and water vapor together. But remember, all these stars and planets are just the foam on the ocean of dark matter and dark energy. Dark energy is the mysterious force pushing the universe apart, accelerating expansion and fighting against the pull of gravity. Some theories suggest our universe is just one bubble in a vast multiverse, each with its own unique laws of physics. String theory attempts to unify gravity and quantum mechanics by proposing tiny vibrating strings and extra dimensions hidden from view. On Earth, we built the Large Hadron Collider to smash particles together, recreating the conditions of the Big Bang to find answers. The discovery of the Higgs boson confirmed how particles gain mass, a monumental triumph for the standard model of particle physics. Yet we still don't know why there is more matter than antimatter. By all rights, the universe should have annihilated itself instantly. Cosmic inflation theory explains why the universe looks the same in every direction, expanding faster than light in its first moments. The cosmic microwave background is the baby picture of the universe, the oldest light we can see, imprinted on the sky. Tiny fluctuations in this ancient light eventually grew into the massive clusters of galaxies we observe in the sky today. From a hot, dense soup of particles to a cold, structured cosmos, the evolution of the universe is a miracle of complexity. We are the universe experiencing itself. Every atom in your body was forged in the fiery heart of a dying star. The future holds megastructures like space elevators, which could make travel to orbit as cheap and easy as an airline flight. Advanced civilizations might build Dyson spheres to harvest the total energy of their star, becoming masters of their solar system. Warp drives, once pure fantasy, are now being researched theoretically as a way to bend space and travel to the stars. Artificial intelligence will be our partner, processing data faster than any human and piloting probes to the furthest reaches of space. The distances are vast. Even at light speed, it would take 4 years to reach our nearest neighbor, Alpha Centauri. Projects like Breakthrough Starshot aim to send tiny nanocrafts to Alpha Centauri using powerful lasers to reach relativistic speeds. They could send back images of Proxima b within our lifetime, answering if the nearest star system is home to life. We have learned so much, yet we are still like children playing on the seashore, while the great ocean of truth lies undiscovered. Why are the laws of physics perfectly tuned for life? Is it luck, providence, or simply the result of survivorship bias? Will time go on forever, or will it loop back on itself? The nature of time itself remains our biggest puzzle. From the quakes of Mars to the dark stars of the dawn of time, the universe is a place of wonder. Science is our torch in the darkness, illuminating the shadows of ignorance and revealing the breathtaking reality of the cosmos. The next Einstein or Hawking is out there right now, looking up at the night sky and dreaming of the impossible. We must keep exploring, not just to survive, but to fulfill our destiny as the consciousness of the universe. If you enjoyed this journey through space and time, please consider supporting our channel to help us uncover more secrets. Don't forget to hit the like button and share your thoughts in the comments below. What mystery should we explore next? Subscribe and ring the bell so you never miss an episode. We have many more stories from the deep cosmos to tell. Thank you for watching The Universe Unveiled. Join us next time as we continue to peel back the layers of cosmic mystery.